All right, so in this section, I'm going to show you how to use trig ratios to find the length of an unknown side of a right angle triangle. Remember, the trig ratios are used to solve a right angle triangle. Now, here's how I would start. So example 6, it says calculate the length of the side indicated by x. So we need to find x. Now, the first thing I would do is identify the sides which are involved in the question. The side in front of the right angle is the hypotenuse. The side in front of the angle is opposite. And so the other side is the adjacent side. So here I can see the two sides which are involved in this question are the hypotenuse, which is 13, and the adjacent side, which is x. Then I'm going to ask myself, and I'm asking you, and you all can answer, which trig ratio includes adjacent and hypotenuse? Remember, I know the opposite is not involved at all because I don't know the opposite. I'm not asked to find the opposite, so it's not involved in the question. Which trig ratio includes adjacent and hypotenuse? Anybody?
Cosine.
Cosine. So I'm going to write cosine is equal to adjacent over hypotenuse. Now, the reason I write that is because the more I write it is the more I'm likely to remember it. Then I'm going to say the cosine of the angle, which is 60 degrees. Earlier, not today, but before today, I told you that sine, cosine, and tangent, the trig functions, are functions of an angle. The input must be an angle. So after you write sine, cosine, or tangent, the next thing you must write is the angle. Then I'm going to say that this is equal to the adjacent side, which is x, over the hypotenuse, which is 13. Then I'm going to put the cosine of 60 over 1. Then I'm going to say, if I have one fraction is equal to one fraction, what do I do? Anybody?
Cross multiply.
Let's cross multiply. What is 1 times x?
X.
X.
Very good. So 1 times x is x. And this is equal to 13 multiplied by the cosine of 60 degrees. The next thing now is that you have to put that in a calculator, exactly how you see it. In a scientific calculator, put 13, then cosine 60 degrees, and then press equal, and tell me what you get. 13,
6.5,
and then press equal and tell me what you get.
6.5.
This is equal to 6.5, and this is meters. All right. Chalice, I'm going to ask you to turn off your camera. I don't want anybody to turn on the camera at all because we're recording it. And if we record it and your camera is on, you're going to get caught in the recording. All right? Nobody turn on the camera. All right, guys. So I did A. I want you now to do B and C. All right, guys. So let us have a look at B. The first thing, the side that is in front of the angle is the side that is opposite to the angle. All right. The side in front of the right angle is the hypotenuse. And so the other side where the 7 is the side that is adjacent to the angle. So the two sides that are involved in the questions are the opposite side and the adjacent side. Then I would ask myself, which trig ratio includes opposite and adjacent? The answer to that is tan, And so I would say tan is equal to opposite over adjacent. Then I would say the tangent of the angle, which is 58 degrees, is equal to opposite x over adjacent 7. Then I would put the tan of 58 over 1, and then I would say, if I have one fraction is equal to one fraction, I'm going to cross multiply. So 1 times x is equal to 7 times the tangent of 58. Then I'm going to put that exactly the way you are seeing it in the calculator, 7, and then tan 58. Then I'm going to press equal, and the answer is 11.2 meters. And this is to 3 significant figure. All right, let's move on to C. So what we did is that we modified C because somebody pointed out to me that C and A were the exact same question. So what I did is I modified C to how you're seeing it on the in the screen right now. And then I identified that X is opposite to the angle 30 degrees, and that the 19 is the hypotenuse. Then I would ask myself, which ratio includes opposite and hypotenuse? The answer to that is sine. So I'm going to say sine is equal to opposite over hypotenuse. Then I'm going to say the sine of the angle, which is 30 degrees, is equal to opposite x over the hypotenuse, which is 19. If I have one fraction is equal to one fraction, I would cross multiply. So therefore, 1 times x would be equal to 19, the sine of 30 degrees. Therefore, x would be equal to put that in our calculator and press equal, x would be 9.5 meters. All right, so we're looking at how to use trig ratios to find the length of an unknown side of a right angle triangle. I'm going to do D, then I want you to attempt E and F, which is on the next page. All right, again, the 7.2 is opposite to the 30 degrees, and X is the hypotenuse. Now, the trig ratio that includes opposite and hypotenuse, same as the question before, is sine. So sine is equal to opposite over hypotenuse. And again, the more I write that statement is the more I'm likely to remember it. Then I'm going to say the sine of the angle, which is 30 degrees, is opposite, which is 7.2 over the hypotenuse, which is x. Put the sine 30 over 1, then I'm going to say, if I have one fraction is equal to one fraction, I'm going to cross multiply. And so this is x times the sine of 30 degrees is equal to 1 times 7.2, which is 7.2. My objective is to find x, so I'm going to divide both sides by the sine of 30 degrees. Sine, cancel sine over here, leaving x is equal to, and so this is 7.2 divided by the sine of 30 degrees, then press equal, and what I got is 14.4 centimeters. And so x, which is the hypotenuse, is 14.4 centimeter. Please take your notes, then turn the page and attempt E and F. All right, let's have a look at example E. In example E, the side in front here would be opposite, where X is in front of the right angle would be the hypotenuse. And so this side where the 6.3 is would be the adjacent side. So then we're going to ask ourselves, sorry about that. Then we're going to ask ourselves which ratio includes adjacent and hypotenuse. The answer there is cosine. So I'm going to say cos is equal to adjacent over hypotenuse. Then I'm going to say the cosine of 60 degrees is equal to adjacent 6.3 over the hypotenuse, which is x. If I have one fraction is equal to one fraction, I would cross multiply. So this is x times the cosine of 60 degrees is equal to 1 times 6.3, which is 6.3. Divide both sides by the cosine of 60. So here this cancels this. And so I'm left with x would be equal to, you put that now in a calculator, 6.3 divided by the cosine of 60. The answer is 12.6 centimeters. And so the length of the hypotenuse is 12.6 centimeters. All right. So let's have a look now at F. In F, the side in front of the angle is the side that is opposite to the angle. The side in front of the right angle is the hypotenuse. And the side where X is the adjacent side. Then I would ask myself, which ratio includes opposite and adjacent? The answer there is TAD. And so I have TAD is equal to opposite over adjacent. And what I said is, the more I write this is the more I'm likely to remember it. And so the tangent of 27 degrees. And remember, every time you write sine, cosine, or tangent, the next thing you must write is the angle. So this is equal to the opposite side, which is 5.8, over the adjacent side, which is x. If I have one fraction is equal to one fraction, I'm going to cross multiply. And so x, this is x times the tangent of 27 is equal to 1 times 5.8, which is 5.8. And if I divide both sides now by the tangent of 27, here, this cancels here. And so I'm going to get x to be equal to, so this is 5.8 divide by the tangent of 27. And so x is 11.4 centimeters to 3 significant figure. X would be 11.4 centimeters to 3 significant figure. Ladies and gentlemen, the trig ratio may be used to find the length of an unknown side of a right angle triangle. In the next section, we'll look at how to use the trig ratios to find the size of an unknown angle of a right angle triangle.